All right, welcome back. Sabbath Algebra 2, Lesson 7-5. Just taking a look, for my classes, we're just going to cover this section real lightly. So here's some of the big ideas that you need from this. If we were going to graph the tangent, when you graph the tangent, sine over cosine, because remember it's opposite over adjacent, opposite side's the y, which is sine, adjacent side. Cosine, again, if you were looking at that on the circle, you have a triangle in there. Opposite side y, we're talking about the unit circle. So the unit circle being the hypotenuse 1. Y over 1 would be just the side. So when you're looking at this and you graph those corresponding coordinates and you put the y over the x in each case, when you're at a negative pi over 2 right down here, remember we said we're talking about y over x or sine over cosine. This x in the denominator, that x is 0, so you're dividing by 0. So at negative pi over 2, actually, or undefined, it's going to be an asymptote. If you go to the pi over 2 up here for the positive rotation, you're going to have the same thing. Asymptote, because x is 0, cosine is 0. You can't have to divide by 0 in the fraction for the tangent. All the others in here, if you plot the points, you're going to have a tangent that looks like this, and then it actually just repeats because of the cyclical nature of our trig functions. When you go to the cotangent, you're going to run into a similar thing, but since you're talking about the reciprocal, so x over y or cosine over sine, it's when your sine at these locations, you're going to be undefined. So those are going to be at your 0 and either at pi or negative pi. So that's why on your cotangent, you see an asymptote here at 0 and at your pi and your negative pi. Talking about key features here, just a reminder that it's increasing everywhere on the tangent and it's decreasing everywhere on the cotangent. And then if we were talking about where is it positive and negative, you've got your positive above the x-axis, got your negative below. So when you're talking about looking at a period on here, over here, one period from 0 to pi, or if you're talking about here on the tangent, from negative pi over 2 to pi over 2 to get a full cycle of the graph. Some people may take a different section. I just think this one makes sense rather than taking half of it from over here and half of it from here, sort of thing. Over here, if you get to your secant, 1 over the cosine, you're going to have an asymptote again in here again, because remember, secant reciprocal with cosine. Cosine, where is your x values? And if we come back over here again, where are your x's zeros? They're at the negative pi over 2 and the pi over 2, so that's why you see your asymptotes there. Similarly, and there's one other thing that's kind of interesting here. If you sketched the vertex, if you think of this as a vertex on these points, if you sketch these in as low and high and connected them, which graph has this shape right down here is actually the cosine. If you do similar things over here with the cosecant being sine, what graph do you get here? Which graph does this? And if it continued right over to here, if you look at this section of the graph, that's your sine graph. So that's an interesting, but you do still have these asymptotes because of where you would be dividing by 0 on the sine at 0. And then if you went over here to 2 pi or at your pi, negative pi. And here, disregard that one I highlighted in there for the sine. Those are kind of the biggest ideas in the section. There are some transformations that come up. To actually do the graph for the tangent, if your x values are going to go here from your for your rotation, because remember what we're talking about here is the x and the y, so negative pi over 2, Remember, this is a negative pi over 2 rotation. And so if you look over here, we're talking again about tangents, so sine over cosine. And cosine being x, what's the value of x down here? That's 0. So you can't have that. Same thing over at when you get to the positive pi over 2 up here. And if you end up plotting all these points and looking at the shape of the graph, you will have that general shape for your tangent. Let's see. After that, just somewhat quickly, just so you have the general idea. For your key features, negatives, positives, this graph for my tangent will always be increasing, always. You do have those asymptotes in there that we talked about on the previous slide. The period, how long does it finish this cycle? From negative 3 pi over 2, or from negative pi over 2 to pi over 2? That's a pi. So my period is pi. Let's see, my range goes down forever and up forever, so that's all real numbers. Domain, you just have to leave out your asymptotes. Your zeros, where are the places where it crosses? So in any multiple of your pi's. So sometimes they'll write that as like pi plus, or in this case, you could just put n times pi, so that so it'll be at your negative pi, your pi, at your 2 pi over here. It's gonna, so any multiple of your pi is gonna end up being on the x-axis. And then your asymptotes, where are they? They're at any place where you have an odd number over 2 times your pi, positive or negative. And so I'll write that out with an n in there as well. Or you can just write it in words. Transformations. So this 2, remember, that's going to be a vertical stretch. That's going to make it vertically 2 times taller. And remember what we did here. So we took, and that 4 means it's going to happen 4 times more quickly. And so for that 4, a larger coefficient, smaller period. So it's going to have the appearance that it's happening quicker. So where it was, more cycles of the graph are going to happen where it used to take 1 the frequency 4. And then if you were actually going to do an application problem, we've done these already, but you've got Seth standing 3 miles away watching the launch of the rocket. The rocket never will be directly overhead. So it's going to just keep going higher and higher and higher, but eventually it looks like it's right over the top, but not. And the final question, identify the domain. Well, the domain x, the angle here, it's going to go from 0 all the way up to, will the rocket ever be directly, because this is as the rocket goes up, this is going to continue to go up, the angle. And when it's up there super high, it might almost feel like it's directly overhead. And then identify appropriate domain, use the function to describe the motion of the rocket. So that's the basic idea of what you're going to work on in there. Secant, 1 over the cosine. So if you took your cosine graph and you looked at it here, I kind of talked about this actually on the opening slide. If you connect your low and high points there, you're going to actually see your cosine graph. And, that kind of the basics of the lesson. Leave most of this to get into when you go to higher levels, but just kind of a real kind of basic overview there.